got our general framework of how to find the inverse of a 3 by 3 matrix, or any matrix in fact. But we're looking at 3 by 3s today. So we want to find the matrix of minors, then the cofactor matrix, then we use that to find the adjugate matrix, and we divide the adjugate matrix by the determinant of our original matrix M, and that gives us M inverse. So of course we're going to go through and define each of these things. The matrix of minors, so for each point in the original matrix at M, we replace the ith element with the ith minor, and that means that, and we did this in the last video for finding the determinant of a 3 by 3 matrix, we cross out the row and column that our components in, and then we find the determinant of the 2 by 2 matrix that we're left with. Okay, so we'll see that later. The matrix of cofactors, but we use our little almost checkerboard matrix of pluses and minuses, and we just go through and change the sign of the matrix of minors, and that gives us our cofactor matrix. Then for the adjugate matrix, we find the transpose of the cofactor matrix, so we just swap the rows and columns over of the cofactor matrix, and then so before all this we'll find the determinant of our matrix M, and then we just divide the adjugate matrix by M, and that gives us our determinant. So we're going to take our matrix M to be equal to 2 minus 1, 3, 5, 6, 1, 4, minus 2, 8. First thing we're going to do is work out the determinant of M. Okay, because we have to divide by the determinant of M, I don't want to introduce 3 new matrices in steps 1, 2 and 3 and then get confused and find the determinant of the wrong matrix. So just find this straight away, and that's equal to 2 times 6 times 8 minus 2 times 1, so that gives us 2 times 50, which is 100, and then we have, well, minus 1, but so that's plus 1 times, crossing these out, we get 5 times 8, right, 40, minus 4, that's 36, so we add that on. Then this last one we get 3 times, crossing out this and this one, 5 times minus 2, that's minus 10, minus 24, that's minus 34. If you minus 3 times 34, you're taking off 102, so our determinant's equal to 34. Okay, so that's sorted. Now, matrix of minors. So for each component, so to get the top left component of this matrix of minors, we consider the minor of this element 2, so we cross out this row, and then we multiply 6 by 8, add, well, we subtract minus 2 times minus 1, but that's adding 2, and we get 50. Okay, we've already calculated these determinants at the top, so we get 36 and minus 34. Okay, so for this one we cross out this column and this column and find out the 2 by 2 determinant of minus 1, 3, minus 2, 8. That comes out to minus 2. Okay, for this element we cross out this one and this one. We find the determinant of the 2 by 2 matrix, 2, 3, 4, 8. Okay, that comes out as 4. And we keep doing this, we get 0 here, minus 19, minus 13, 17, and as you can see, this can be quite a tedious process, and I'd encourage you to learn to calculate 2 by 2 determinants in your head without having to write them down, because this will be a lot quicker for you. You don't want to be writing down all these calculations. Right, so that's step 1 complete. now we want to do the matrix of cofactors. So if you remember our little checkerboard, it's plus, minus, plus, minus, plus, minus, plus, minus, plus. So all we do is apply that to this minor matrix. So keep the sign the same there. Then we get minus 36. We keep the sign of minus 34 the same. Then we have minus 2, but we've got a minus sign here, so we have to change the sign. So that's 2, 4. Well, we get minus 0, but that's just 0. And then we keep minus 19 as it is. Then we get 13, 17. Okay, so we're almost done. Now we want the adjugate matrix. And all we do is swap the rows and columns around. So 50 minus 36 minus 34 just goes down as a column instead, and then we get 2, 4, 0, and then we get minus 19, 13, 17. You'll notice that this leading diagonal stays the same, but everything else sort of flips. Okay, so we're almost done. Now for our inverse of M, we just divide the adjugate matrix by the determinant. And that's our answer. I mean, we could multiply the 1 over 34 in and simplify, but I'm happy to leave it like this. Hopefully you understood the method. Last thing I will comment on is you can apply the same with 4x4 matrices. But what you got to remember is, if we got a 4x4 matrix, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So to calculate the minor matrix, we'd have to cross out this one, and then we're finding the determinant of a 3x3 matrix, and we have to do that for all 16 elements. So you can see this would take forever by hand. So we, I've got some videos on Gauss-Jordan matrix inversion. If you want to check that, it's a different method. It's not covered at the A-level syllabus, so we won't be covering it in this series. Or we can just use a computer to do this, because otherwise it's just ridiculous. So anyway, if you did enjoy this video, please be sure to like and subscribe. If you've got any questions, let me know down in the comments, and I hope to see you in the next one.